In this video, we're going to talk about reflections. Remember, reflections are just a flip across a certain line. So when we're reflecting, we usually reflect either across our x-axis or our y-axis. Let's look at these two reflections that I have. What did they reflect over? Well, remember, a reflection is like a line of symmetry. It's my fold. Where did I fold it at so that if one ended up on the other one, it would be an exact mirror image? Well, on the first one, this right here is my line of symmetry. So that is my x-axis. This was a flip across the x-axis, or a reflection across the x-axis. What about the second one here? Well, my line of symmetry would go right along my y-axis. So this is my line where I'm folding it up. So if one was flipped over, mirror image. So the second one is showing me a reflection across the y-axis. Be careful, make sure that you are seeing exactly where your line of symmetry is. If you can draw your line of symmetry, it makes saying whether you're reflecting across the y or the x-axis easier. Don't just go ahead and say, hey, I moved to the left or right and think that's your x-axis. I know my x-axis goes left and right, but it's flipping across the y-axis. So let's actually do a reflection. Reflect this rectangle KLMN over the x-axis. So the first thing I'm going to do is draw my x-axis. I want to make sure I know this is my line of reflection. I'm flipping it over. So which quadrant should my new image appear in? Well, it should appear down here in quadrant 3. Now, when I'm doing a reflection, I'm going to take each point. I'm going to see how far away it is from my line of reflection and do the opposite. For instance, if I were to take M right here, I know that M is on this line and M is 4 units up from my x-axis. So the new M is going to be 4 units down from the x-axis, and I'm going to name it M prime. What about my L? L is 6 units above my line of reflection, and so it's going to be 6 units below my new line of reflection. Let's take the other one. What about N? N is 4 units above, so its reflection is going to be 4 units below for N prime. And K is 6 above, so it is going to be 6 below. Whenever you're done drawing your with each point, my new figure should be congruent to my original. It's the exact same shape. It's just been flipped over. So what actually has happened here? Let's see if we could go ahead and write our algebraic rule. Let's take one point at a time and see what's happening there. Let's take M. M ended up starting at -3, 4. -3, +4 is where M started. And M prime is now located at -3, -4. Well, what happened or changed here? Did anything happen to your x value? X value stayed the same, so we're going to write x value is going to change and stay x value. But what about our y value here? Well, I can see that my y value changed to the opposite. So remember to write to the opposite. I'm going to write -y. -y doesn't always mean it's going to be changing to a negative. It just means it's going to be the opposite of what it started at. The opposite of 4 is -4. If my original figure had been a negative number, then now it would be changed to a positive. Let's make sure that holds true for some of the other points. Pick another point. Do you want to pick L, N, or K? Let's look at L. L originally started off being at 3, 6. And now my L prime, my new L, is located at -3, -6. So did our algebraic rule hold? Well, our x value stayed exactly the same, and our y value changed to the opposite. Let's try another one. Reflect over the y-axis. So let's first identify our y-axis. Our y-axis is right here. That's my line of reflection. So I can see that when I reflect it, it should end up over here in quadrant 1. Let's do one point at a time. Remember, let's start with L. L is starting off over here. It is 3 units from it, so I need to do 3 units the other direction. So my new L is going to be located right here, L prime. My U, it is 3 units to the left, so I need to do 3 units to the right. Go in the complete opposite direction. That's my u prime. And now my last one, x. Well, x is right here on the line. When I reflect it over, x is not changing its location. It's on the line. It's going to stay on the line. So my new x is going to stay exactly where x was originally. Now I'm ready to connect my points. Remember, whenever we draw our new figure, a reflection should be congruent. All that's changed is it's changed its orientation. It has not changed size or shape. So what actually happened to our algebraic representation here? Let's take a point. Let's go ahead and start with L. L started off being at -3, +1. And my L prime is now at 3, +1. So what changed here? Let's look at the x value first. My x value was at -3 and now it's +3. So it changed to be its opposite. Remember to write that it's the opposite. I write -x. That means the opposite of x. What did our y do? Well, our y stayed the same, so I'm going to write down that my y stayed the same. Let's go ahead and check that that's true for all of our other points. U was at -3, +5. And now my u prime is at +3, +5. Well, my my x value changed to its opposite, and my y value stayed the same. What about that x value, the one that we weren't really sure on since it stayed? Well, x value, it started at 0, +5, and now my new x prime is at 0, +5. Does that hold true for this? Well, it said my x value is the opposite of x. Well, 0 is the only number that does not have an opposite. 0, the opposite of 0 is still 0. It doesn't change a sign. And our y value stayed exactly the same. So using our rule, I can see that that new point x prime should have stayed at 0, 5.